I've noticed a lot of the dashboard cameras come with these typical, you know, cigarette lighter plugs with the sort of 12, 24 volt in, 5 volt out. And one of the most common places they fail is right here at the strain relief, which isn't a strain relief, it's really quite rigid, and it's supposed to bend a little bit and take the strain off the cable, but the cable always snaps where it goes in here. So let's see what we can do about re-terminating that. So for a start, since I'm just going to, let's cut that off in fact. Let's use a cheapo pair of snips of this. Pow! Right, we'll get that bit out of the way at the moment, and we'll get into this. So, if you unscrew the end of this, it's got a fuse in it, and then it's got this little metal ring in the end that is supposed to come off, which is probably not going to come off for me now. Oh, it's just come off. And then if you gently prise it, actually there's a label on this I noticed, which I'm going to have to break. Here's the knife. Let's break that little label. There we go. And it should now kind of prise open. Maybe. Maybe it won't. I don't think there's a screw in here. I don't know if this one's clipped. Most of them are just sort of usually clipped right at the very end. So, rightio, there we go. Oh, quite a beefy little one, I have to say. Is the chip marked, just for reference? What's it going to be? It's a... Oh, that was the right way up. AD85063D. Okay, quite a beefy little choke there. It just kind of floats around inside. Right, so let's pull that out, and here's the bit we need to know here. So we have to remember where these connections go. So I'm going to cut it off, but actually leave a bit of those wires on. And here's the tricky bit, because it'd be really nice if you could just pull this out the middle of this, and you can certainly pull the middle cores out, but the outer sleeve is physically moulded in, and you may have difficulty prizing that out. And this is where it sometimes helps just to grip it in a pair of pliers and drill it out. So let's do that. What sort of diameters? This is about 4mm diameter, so I'm going to use a 4mm drill. Let's get the drill out. And this is also the opportunity to drill your fingers. Oh, actually, no, let's go for a 3.5mm drill. That looks closer. That's just over 1/8 of an inch. And this is definitely something you want to hold this in a vise or something, because it's very prone to just for the drill to just pop right out the side and into your fingers, which is never a good result. So let's stick this in a vise. And we'll try and drill this out now. Might not go very well. It's already not going very well. I'm going to make a mess of this, aren't I? For your merriment. I'm going to try and drill right down the middle of this. I'm probably just going to pop right out the side at an angle, but not to worry. If it does, it does. Oh, and it has. Not to worry. That'll do. It's still better than it was before. Right, let's see what sort of mess I've made. Oh, I've made a hideous mess. It really has just popped right out the side. Do I care? Not really. Yeah, something like that. So let's get that cable that I've already cropped, and we'll shove it in through this big mess that I've made from the correct side. And we'll strip that by nibbling it delicately. Just nipping the insulation at the edge. Fairly brittleish insulation this, it's a fairly brittleish PVC. So once you've nibbled it lightly, bend it until it snaps and then slide it off, and that's you strip the cable. Right, so the negative is going to, strangely enough, the same lead as the negative of the LED. The positive is going to the one next to it. Rightio. Don't forget where it went. If in doubt, take a photo before doing it. Stripping this, I may use a stripper here. I could actually use a pair of the cutters. The wires are super thin. You know, it says on the box that this is rated 1.5 amps, and then you see this wire and you think, well, yeah, not overly impressed with that. But at least it is copper because it's twisting nicely. You know, I've noticed that thing about, you know, that other wire you get that is copper plated, but it's not actually copper. When you twist the strands, the single most annoying thing is you twist it and then it just goes boing, 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 and it just unwinds and they're straight again. That happens all the time with that stuff. It's one of the characteristics you can use to detect it. I'm guessing it's the aluminium cord, copper coated aluminium wire. It's shit, it's rubbish. Don't like it. Not nice to deal with, but I suppose the Chinese manufacturers are only really interested in the economy aspect. So let's tin these wires, ready for soldering back on. I might also be tempted to stick a cable tie on the inside of this to stop the thing being pulled out. I'll do that afterwards, that'll be a good idea. Now I can take these wires off. And I'll flood some fresh solder onto those connections. Oops. A bit too small for my big fingers. The peril of being big fingers. Not very delicate and subtle. I could have left those wires a bit longer, that would have made it slightly easier. And I'm just saying, why don't you use the helping hands? And the answer is because I'm quite stubborn. They're a last resort. Rightio. So I'm going to just touch some solder onto these. Fresh, glorious lead-based solder. I'm going to put the negative on first. It's going on there. And because there's a couple of pads there, I'm just going to solder it right across both of them, because that way I don't have to crop it short. I am, however, just going to crop this a little bit because it's going onto a single pad. So this is tinned, the wire's tinned, the pad's tinned. Let's stick this back on. Now what do I have that I could use as strain relief to stop this being pulled out? Let's sit this back in for a start. Oh, you know what? That negative has just popped right off. That wasn't soldered on very well, was it? I'm guessing it was soldered on. Yeah, it was soldered on. It's supposed to be soldered on there. I'm going to need the vise. Actually, I'm going to be unstubborn. I'm going to get the helping hands in for this one because and I'm going to grip it in a really awkward way that will make it ping out explosively. No, maybe I'm not then. And then spend the rest of the video chasing it around the room, hunting high and low under mounds of electronic tat. So let's get some fresh, rich, full-bodied lead-based solder onto this and make the connection properly like it should have been done in the first place. Oh, my stomach protests. Right, that's better. So this hooks in like this. These things are just so kind of, well, they're optimized for mass production. They're kind of a bit tacky really, but they work. The spring just literally sits in like that. Can that wire go down the way though? Or is it going to have to? Yeah, that'll do. The circuit board just kind of dangles around inside. It's held literally in place by the one pin that the LED hinges around. Isn't that just absolutely horrific? And then I'm going to use a cable tie around that to stop that being pulled out because there's nothing there otherwise. Cable tie, cable tie, cable tie. All I need to do is find a cable tie. Easier said than done. A bright yellow cable tie. Perfect. So let's pull that nice and tight onto that so it locks onto it and bites into the plastic just enough to stop that pulling through. Then, oh dear, there really isn't a lot of room in this, is there? Then we shall put it back together. It really does, the circuit board just flops in there. It's just not held in with anything, it just sits. That's just so weird. Make sure everything's in place. Then this just theoretically it just presses back together. It's got one little sort of clip here at this end that hinges. Then the little metal ring goes over the end, the little metal ring that I've just momentarily lost. Make sure these springy bits are working okay. Yes, they are. The fuse goes down the end, plop, onto the spring. Then if this is parted company, the little pip goes over the end of the fuse. Ugh. Well, better just sitting it down there then. And this is the point you then plug your 5-volt appliance in and find you got the polarity wrong. There's a loud bang and smoke comes out it. But yes, what can I actually test this on? Have I got anything I can test it on? Not really, actually. Nothing that I particularly wish to test it on that's low value. Ah, yes, I know what I can test it on. A cheap and slightly mutilated dashcam. Assuming it's got the correct connector, but most of these things seem to use the large USB. So there we go, the mini USB, should I say. Right, power supply, and I'll just stick 12 volts on this and we'll see what happens. Ideally I'd be able to test just off the end of the connector, but that's not going to happen because it's tiny and there's nowhere to really connect onto it, so I'm just going to have to go for the full-on test here. So negative onto here and positive onto there, and the little red LED's lit in it and it seems quite happy and no smoke's coming out, so that should just be fine then. Please insert SD card. Yep, that's a good result. That's the strain relief momentarily improved. One other thing I could have done here, if I'd really been thinking far enough in ahead, I could have put some heat shrink over that just to make the cable more rigid, but at least it's not really biting at the edge anymore. It's got a bit of slack there now, so it should last a bit longer. So good result.